Hi, and welcome to the Azure Database for MySQL monthly webinar. I'm Shreya R. I'm a product manager in the Azure Databases team. Today, we have a very special episode introducing and featuring industry experts from Microsoft's esteemed partner organization, which is Tata Consultancy Services. And most of the talks in today's session will be around building low-code serverless applications on top of your Azure Database for MySQL workloads using Azure Functions. Today, as always, we are live on LinkedIn, YouTube, as well as Twitch. If you missed any of our previous webinars where we had several experts talking about everything MySQL and Azure MySQL, you can check out the recordings on our YouTube channel. Our handle is at Azure DB MySQL. And one more thing before we get started, if you have any questions or feedback during the webinar, or if you want to let us know what topics you would like us to cover in future episodes, please leave a note in the live chat window and we'll address them as we go through the session. All right, so let me move on to show you what the agenda looks like today. So first, we have a short talk by Sai Kondapalli announcing the support for Azure Database for MySQL trigger bindings for Azure Functions. Next, Enterprise Architect Biswajit Dhar and Technical Architect Abhirup Haldar from Microsoft partner Tata Consultancy Services, that's TCS, will demonstrate how to use the Azure MySQL input, output, and trigger bindings for Azure Functions to quickly and easily solve real-life complex problems through automation. And finally, I'll walk you through the latest updates in Azure Database for MySQL and share with you the upcoming roadmap. So let's get started. Azure Functions is a serverless solution that allows you to build robust applications while using less code, less infrastructure, and low costs. It is particularly useful to really quickly and easily build systems and solutions that react to critical events. For example, events happening in real time, like responding to database changes or processing event streams or messages. And the Azure Database for MySQL bindings for Azure Functions allows you to bring all these benefits of Azure Functions to build useful and innovative solutions on top of your MySQL workloads on Azure. So I'd like to welcome Sai Kondapalli, Senior Product Manager in the Azure Databases team, to talk about these bindings, especially the newly released support for triggers. Hi, Sai. Thank you for joining us today. Could you briefly introduce yourself before jumping into your presentation?
Thank you so much, Shreya. Thank you for having me here. This is an incredible opportunity to talk to our customers, partners alike, who are like really interested to learn more about Azure Database for MySQL, the features that we have to offer, and how enterprises are leveraging the features and integrations that we have on our platform today. With that, let us dive into the bindings and the functionality that is available for MySQL with Azure Functions. So before I briefly dive into the binding side, can we move on to the next slide, Shreya? Thank you. So before I dive into the actual bindings and how they help customers leverage these on the application side for code development, let me just give a brief background on why we thought about integrating MySQL with Azure Functions. So, as you all know, in the recent times, the technological landscape has been developing quite drastically, and enterprises and customers would love to move to microservices and serverless event-driven applications in nature. And to manually integrate transactional backend data store with Azure Functions is a cumbersome task for customers, and the ability to maintain millions and millions of lines of code for this boilerplate integration is pretty huge of an undertaking for customers. So we have been requested by many customers in the past, like, hey, is there a seamless integration where we can simply connect MySQL with Azure Functions and can do many of these things in real time without having to worry about the code maintenance, etc. And that is where the integration of MySQL with Azure Functions comes into picture today. So moving on, we have capabilities that we already introduced during Ignite 2024, which is input binding, wherein Azure MySQL can communicate with Azure Functions, and the code runs on the function side and can query the Azure Database for MySQL backend database to fetch data, process the data for the application side. And moving on, we also have something called output binding, where the function can process the data and place the data back into the MySQL table. This could be insertion of new records, updating of new records, deletion of new records, etc. And currently, we are introducing what we call as MySQL trigger. This is offering much more functionality in serverless event-driven application scenarios where if a change were to happen on a MySQL table, that change can be immediately detected by Azure function, and you can perform multiple things on top of that, such as, for any e-commerce related applications or any for financial data where the data is changing, you would like to track whether there are any risk analysis that you would like to perform on the database server, etc. So along those lines, we have MySQL trigger. Now, let us dive a little bit deeper into what triggers are. So triggers are reactive event-driven solution that provides an efficient change tracking mechanism for application. So any record that is existent in the table and that has any changes that are happening on top of that, you can track those changes and you can have your function perform further analysis on top of that for your applications. And you can manually enable change tracking on a table by table basis by altering the table structure wherein you will add a column, and that will help to detect any rows that have been changed on the table through the functions. You can monitor one table or more tables or all of the tables, user tables on your database server for any data changes that are happening during the change tracking procedure. A simple change data capture architecture that I would like to portray here is I have a table, and whenever I make some updates on this table, I need my Azure functions to detect the changes and feed the data into Azure Event Hub. And from Azure Event Hub, I can do a bunch of things like, I can connect it into Power BI for any business analysis, or I can connect it to blob storage for further analysis, like, for any data retention for over a period of time, and move it into cold storage. So here, as you can see, I'm making an update on my MySQL table, updating the products table, setting a new product price. And now, as soon as the commit happens on the database table, the MySQL trigger binding automatically detects these changes, gets those, process it further, and sends it to Azure Event Hubs. And from Azure Event Hub, I can consume it in many number of ways that I just proposed, which is like, store it in an Azure Blob Storage, or maybe even pipe it to Power BI so that, I can build some beautiful dashboards on top of that. And with that, let us invite our awesome partners from Tata Consultancy Services. Hello.
Hello.
Hi.
Hi, sir. And thank you for having us.
Thank you so much for taking the time to meet with us today. So why don't you introduce both of yourself and talk a little bit of about Tata Consultancy Services as well.
Okay. So, Tata Consultancy Services, or TCS in short, we are an IT services consulting and a uh, business solutions organization. Next slide, please, Shreya. So, we had been partnering with some of the world's largest businesses and transforming their journeys for over 56 years. So, and we are a 607 over 607,000 strong team. We are spread across 55 countries, and we had been helping our customers across the globe. And and then we are at about, I think, about $29 billion revenue company. Talking about me, so I have about 26, I think over 26 years experience, and had been with TCS for over, I think, 22 years. Started my career around Microsoft technologies, VB6, VC++, and had been graduating and had been seeing the entire Microsoft portfolio evolve over the years from .NET 1 to .NET Core 8. I mean, starting of Azure Cloud and then like that. Currently, uh, I am primarily interested and I work around Azure cloud architectures, around generative AIs, uh, GitHub Copilot usage, customizations around that, creating extensions around that. And I also strategize and with our client in helping them migrate their databases to cloud. I'm also there on LinkedIn, so do feel free to connect with me if you want.
Abhirup.
Hey, hi, Sai. Hi, Biswajit. Hello, everybody. I am Abhirup Haldar. I'm working in TCS for the last 22 years. Throughout this journey, I mostly worked with the RTBMS, solutioning, design, architecture, migrations, homogeneous, heterogeneous, cross platform. And due to this, I have to also worked on different platforms like Linux, Unix, Windows rarely. Currently, I'm working with Azure Cloud, and I'm mostly into the database part again, doing the testing, migration, etc. Also, primarily, I am into the MySQL previews. I participate in this, the private ones, public ones, and I share. I work closely with the Microsoft team all together for this. And I also work on generative AI and Python. And today we are here to understand the new feature of MySQL bindings with Azure Function app, the features, the best part, and how it can actually help you to use it in a much better way compared to the native ones.
Amazing. Thank you so much for the introduction, Biswajit and Abhirup. And why don't we quickly talk about some of the use cases that enterprises can tackle with the integration of Azure Database for MySQL with Azure Functions now?
Okay, so if we really categorize different ways of what we see in the industry about how functions are used, so the first use case that comes in mind is around RESTful APIs. Now, these RESTful APIs for simplified APIs, which are used in some websites, primarily around, say, Jamstack kind of websites. These are common use cases where you publish one or two websites, one or two APIs, which are being called from those websites, which stores the data for further processing, like for contact us and things like that. The other area is for backend APIs for mobile applications, and also about, usage around microservices. On the other side, what we see is around real-time data processing, where we process different data. I mean, for every different kind of entry that we see. So we update another table, or we make further changes, or we push some data to some downstream applications. Two common examples that we have put around here, maybe in some financial applications, if you make some ledger entries, you need to update the trial balances, or you need to update stocks if you make a sale or purchase kind of entries. The third different category of application usage is around IoT applications, where you have different sensors. You have big factories with multiple sensors which are sending so much amount of data, and you need a scalable solution. Now, these are usually simple API calls where sensors just send the data. So Azure Function becomes a very good use case for that, as it scales a lot, and simply adding a new sensor is not something for which you need to handle the underlying infrastructure in such a heavy manner. So on the fourth type of thing, we have real-time data notification or database synchronization, where you may need to send some notification to whenever there's some entry that is made in, say, in a table, or in a MySQL table, or you need to synchronize any of the entries with any downstream database or an application. And finally, another interesting use case comes up where, as soon as we have trigger binding in case, and that is around custom audit trail, which is often an ask for some of the critical applications, where you can implement uh, trigger bindings to create custom audit trails, and so that any entry or any change that is made in that application can be traced. So as part of our demo that we'll be showing all these at a typical use case for user management, and we'll be also showing how audit trailing can be done using this, using trigger bindings for Azure Functions.
Amazing. We are really excited for the demo. And why don't we just, simply dive into the demo side of things?
Yeah, sure.
Hey, Abhirup, your screen's already shared. You can directly jump into the demo.
Okay, is my screen visible?
Yes.
Okay. So let's get down to the demo. So this is a very small application we have prepared over here. It's a small React application, and all the functionalities of the applications are basically done from the Azure Functions using an API call. And in the Azure Functions, we have actually used MySQL bindings. So while we go for the authentication of the application, let me tell you how this application actually works. So it's a very simple application where we have two type of roles. One is the admin role, and the another one is the user role. The admin people who are having the admin roles will be able to view all the users and can edit the users, including themselves. And the people with the user role can only edit or view their own profiles altogether. So now I have logged in with the John admin. So John admin is basically an admin user, and that's the reason why you can see the list of users over here which are there in the organization. So if I click on any one of the users over here, I will be able to view the details of the users over here. So let me tell you this, all these details and everything is actually fetched with the help of the Azure function from a MySQL database. So I click on any of the users here. This one, if I click, all the details are coming down over here. Now let us take a quick action. Let's see what happens if you are just going to, edit any one of the users. So let me take admin chain. So here, say for example, I just make some changes here, make it straight, and then make it as my city, and it is this one is my state and my country. Let me change the mobile number, say all ones, maybe the age to 53. Okay, so I made all these changes. Okay, and I'll then click on the save button. So the moment I click on the save button, what will happen is that upsert operation is going to happen in the MySQL database using the output binding. So let me save it. So now let me check what happened to admin gen. So in admin gen, you can find out that all the changes what is there is actually been done. So you see here the changes has happened. Okay. Now let me see what is there in the logs. So if I just scroll down, you can see that there is an entry in the logs viewer where it is telling me that I have done some operations on admins and user and has happened at this time. Okay, so this particular entry has happened into this log viewer table altogether using MySQL trigger. Now if I go to some other user, say I go to say Charlie Brown, this guy is basically a normal user. Okay, so here you can see it's a normal user, so it can see its own profile only. And if I now change something over here, say this one to old state, and then I go to make it as 50. Oh, sorry. Let's get me back once. This is having a small problem. I'm making just a minute. Some issue I need to check altogether. I just make a small change over here and then make a save over here. If I come down back over here, I can see this is an old state. And if you go to the logs, Yes, Charlie Brown, some changes happened over here. It's an update operation and has happened during this time. So this was all about the application which is there. Let me now switch to the code. So this is my Visual Studio Code. Here you can see this is the project which I'm having. It's basically a Python function, and this is the project structure altogether. Okay, and this is to tell you this is basically the V1 model. In the V2 model, the structure is a little different and the coding style is a little different, but overall the thing remains the same altogether. So to start with, let us start with the some of those basic files. So let me click on host JSON here. So here you can see the version is given over here, and the most important part is there, the extension bundle. So the name is basically Microsoft Azure Function Extension Bundle Preview, and the version is basically Photostar or 5. So that means it is going to use the latest version altogether. Currently, the latest version is 4.29, and if you want to check whether it is using the latest version or not, what you can do is that when you locally test the functions using func_start, just add minus minus verbose with it, and in the logs you will figure it out that what is the version of this extension bundle preview it is using it. Okay. Now then we move to the local settings.json. Here we define the variables. You can see over here. So the most important one is this, the MySQL connection string. It actually connects with the server. So the server is MSFT demo. And here you give the database name, UID and password, everything, and the other parameters all together. Okay. Getting down to the P file, just have a look. For the Python part, the Azure function, this is the version you should be using it. This is the latest one, and you should be using it just to avoid any kind of problem. Nothing more than that. Now let us go with the functions. So as I told you that the application was using all the Azure functions. So first one is the authenticate user. This function is used for authenticating the user. That means when I'm authenticating it, this is basically calling this particular function altogether. The create user is another function which is going to create the user, or it is going to update the user. I've shown you the update operation that has been done through this particular function. Delete user, well, there was no functionality, but this functionality is also there where you can also delete a user. Then you have the get user details, basically the details of the users you're showing on the screen about, say, Charlie Brown or the admin Jane. Those details have been fetched with using this particular function. Then get user log is basically going to show you the log in the log viewer. List user is basically going to list the details of the users in the admin screen rather than the landing page of the admin screen. And then log user changes is basically the function which basically uses MySQL trigger bindings to monitor or to capture the changes that happens on the table and to do the necessary operation of logging it into the log table. So before I start doing it all these operations over here, this is something what we are supposed to check. We will be doing it to have a check in the database. So let's see the database once, how it looks in the database. Okay. So as I told you, the database, so let me see, show databases. So my database is MSDemoDB. Okay. So here I've got two tables. One is a users table and there was a user log table. So let me describe this users table first. So if you look into this users table, this is basically the columns where I'm actually, data is actually been stored. The reason I'm trying to show you over here is this is a very important column. Okay. This column has to be added into each and every table where you want to enable MySQL trigger binding, because this is that column where it actually is used by the monitoring purpose, and it actually captures the data, the current timestamp from here, and the operations also from here. Okay. And if I just show you that user log table, that is a very simple one. Let me check the name of the table. So here you see I have not used any kind of this one, because on user log table I'm not using any kind of MySQL trigger bindings. Okay, so let me go back to my Visual Studio Code. Now I will do one thing. I will just walk through some of the functions. Let me start with authenticate users. So if I go to init.py, this authenticate user is basically using MySQL input bindings. So here you can see it is going to, we've shown that we are giving that user ID and password over here in the screen. So that gets passed over here. And after some verifications, it is going to check with the database whether the user exists or it do not exist. If it exists, it is going to return me the role, name, and the email details. And if it is not existing, then it is going to give me nothing in the output. It's going to give me some null value. So just have a look into this particular item or items, okay? And here you have got the exceptions over here. Now let's see what is there in the function.json. So in the function.json, you have got a section for your HTTP trigger, a very normal one. And here is the one which is of interest. This is a MySQL input bindings. So the type is MySQL, the direction is in, showing input binding, and the name is auth items, which I have actually referred in init.py. Okay, it is using the connection string, the MySQL connection string, which is actually defined in local settings.json. And here is basically the command text. This is somewhere I'm actually fetching the record or authenticating the user. So I'm just simply authenticating it. From here, I'm selecting the username and the password from the database itself. So it returns nothing, that means the user not present. Or if it returns something, that means the user is definitely present. Okay. So this is one of the example of your MySQL input bindings. Let me go for output bindings. So this one, create user, actually uses output bindings. It's again a very simple program altogether. So here, we are going to take the request for in the form of a JSON. If it is not proper, some validations are there over here. So for example, if I'm using upsert operation, obviously I won't be using the password. And if I'm using an insert operation, obviously I won't be using the IDs. And one important thing, as I told you, this is the column which I'm specifically going to set it properly so that my trigger functions are going to work properly. Okay. So now some validations over here, and after some validations, either it is going to create the record or it is going to update the record altogether. And there is a small error sections over here. Let me go to the function.json for this particular function. Here the script is init.py, that's okay. And here you can see it's in the section for your HTTP trigger. Here comes the interesting part. So there is the MySQL, the name is items are given over here. Direction is out, which shows it is output bindings, and it is basically working on the tables users using the MySQL connection string. So here, this delete users or get user details, everybody is basically either using an input binding or an output binding or a combination of both to fetch or to create the records or to commit the records in the MySQL database. Now let me go to the MySQL trigger bindings area. Here comes my program. What I actually do is that it is basically going to check that, what kind of changes are going to happen over here. So it loads the changes over here, and then it actually uses the log items to just do the logging of the operation that has been detected by the MySQL trigger binding into my log table. Okay. So if it is an insert operation, it will tell it is an insert operation. If it is an update operation, it's going to be an update operation. So basically, I'm going to use this item part to do the necessary changes to capture the changes from the users table and log it over here using the log items. I'll show you the same in functions.json. Okay. Yeah, here it comes. So here you can see the type is basically MySQL trigger. It's always in one, and this is a change users on which it is working. Using MySQL's connection string, it is going to basically do the CDC, the capture the changes that is going to happen on the users table. Okay. And the second section, you can see it's very simple output binding, where I use basically MySQL and output binding. The name is log items, as I shown you earlier. Using MySQL connection string, it is going to insert the records in user logs, which is actually shown in the application in the log viewer or in the logs link altogether. I've shown these both the tables to you earlier in the database. Okay. Rest of them, if you look into it, these are again the simple ones. So if you say get user details, it is just going to get the user's details altogether. Again, in the same way, in the functions JSON, you're going to here you can see one thing. Here I can see I can define multiple such items over here, names over here. So one I'm using basically user details, the other one I'm using login user details. Both of them are basically fetching almost same kind of records with a little differentiation. One is basically going for a VAT loss, where you're using the username as this one, and another one is going with the logged in username. So I can define multiple number of such strings over here and call in my applications altogether. So this is all about the function over here. Now, if I just switch to the database once again, I'll just show you some few more things. So if I go to show databases, what happens? I'll show you one interesting thing. So this is basically a schema or a database which has been created automatically whenever you trigger MySQL trigger bindings. Whenever you initiate this one, this particular schema or database is automatically created. So let me see what is there inside this database altogether, what it creates. If I do show tables over here, you can see there is one table called global state, and the other tables are called the leases table. So the global state table, what it contains, let me see. I will do from global state, and it tells me, I have done some operations today itself. So it is showing me that last poll time is this one. Okay, I'll show you how this poll time changes a little later. Now here, basically you have the function ID and you have that user table ID over here. And the last poll time has been shown in the global state. And these two IDs are used in default to create the lease table. The lease table contains the changes that happens in the tables on which, these lease tables are created. For example, if I'm doing some operations on the users table, it is going to create this leases table from my users table, and I'm going to capture the changes out over there. But the moment it quickly it removes it once the operation is successful also. So if you look into the structure of this one, I'll just show you. This is the structure. So here you got the ID, here you got the attempt count, you've got the lease expiration time, and you've got the synchronization completed time. Okay. So what happens is that if there is some problem with the synchronization or with the attempts, some network failure or something like that is unable to update the database, here you can view it over here. For example, our operations are all successful, so it should show that this particular table is a very clean table altogether. So this is a table. You can see it. The naming convention is very simple: leases underscore function ID underscore table ID. Okay. So if I just do a simple select from this table, it says nothing is there. But if you are really interested to find that how it looks like, so I'll just do a select of another one, which was a failed one actually. Sorry. So here you can see, there are some problems with my expiration time, some attempt count has increased, this data has never got synced or got synced a little later or something like that, and that's why these entries are over here. You can see this ID numbers are also a little haphazard in fashion altogether. Okay, so this is done. Now if another point I just want to say is that this leases table, okay, if you want, you can even name it. Okay, you can give a custom name to this particular table for a better identification in case we're having multiple number of tables altogether. Okay, now Even if I try to do something, say if I go to my application, okay, let me do one thing. Let me just try to, right now, if I run this one, there is no empty set, okay? So I'll make this command ready. And let me try to quickly do one thing. Let me see if I just log in as admin John. I take, say this one, okay? I make this one as something of this sort of, okay? And then I just click on save, okay? Save, switch, enter. No, because the operation is so quick that this one got changed. The logs are also over here, but I'm unable to show it to you that, there was an entry and that also got vanished. Okay. So that was all for this demo on your MySQL input, output, and trigger bindings.
Amazing. Thank you so much for walking through all of this, Abhirup. It's really informative.
Thank you.
Definitely. Thank you so much, Biswajit, for all the real world use cases, and Abhirup loved the super insightful demo. I'm sure people can actually start building Azure functions just by looking at this demo. So thank you so much for that. And all in all, thank you for the wonderful partnership so far as well. We really look forward to continuing and, in fact, strengthening the TCS Microsoft alliance going forward. But folks, if you want to learn more, here is the documentation that you can check out. And on the chat, I see a couple of comments from Olche. Hi, Olche. He was one of our speakers in the previous session. And he says a couple of things about how the trigger support has really helped, is really going to be helping a lot of use cases. So thanks so much, Abhirup and Biswajit. And thank you, Sai, as well.
Thank
Awesome.
you.
Thank you.
Great. Moving on to, just give me some time. Right. So let's move on to the last section of the webinar. Here we go. So we're going to cover Azure Database for MySQL's latest feature releases and announcements, as well as the upcoming roadmap. First, the latest releases. We are excited to announce the public preview of MySQL Discovery and Assessment in Azure Migrate. With this feature, you can now use Azure Migrate service at no additional cost to discover MySQL servers in your IaaS or on-premises environment, assess them to identify their compatibility for moving to Azure Database for MySQL, and receive compute and storage queue recommendations as well, along with their associated costs. To learn more, I'd suggest check out the announcement blog and demo video at aka.ms azure-migrate-for-MySQL. The next big update that we had in the last couple of months is unified migration experience in Azure DMS. We are pleased to announce the public preview of this feature, which offers a centralized migration experience for both logical as well as physical migrations. This means that you can now have a faster migration path with really minimal downtime, all thanks to the physical migration capabilities that we actually introduced in the Azure MySQL import CLI. I'm sure some of you have used it. DMS now provisions the target flexible server, restores the source server's physical backup files, which are taken using extra backup, Percona extra backup, and stored in Azure Blob Storage. A similar process to what import CLI had, but all of this integrated into the Azure DMS service. So to learn more, you can check out the link that I've shared on the screen. And of course, we are continuously working on enhancing these two experiences. While they're currently in public preview, they are ready to use, but we also hope to go to GA later this year. Next, we have a bunch of exciting features in the roadmap. The accelerated logs feature, which went GA last year, giving you 2x performance for your servers in your business critical service tiers, again at no additional cost. We are currently working on bringing all the goodness of these features to your servers in the general purpose service tier as well, tentatively by the end of this quarter. Next, the support for MySQL version 8.4. We released this in public preview in October during Ignite. MySQL version 8.4 is the latest LTS release from the community, contains a lot of improvements, as you can check out on the MySQL docs. We are looking to make this generally available by the end of this quarter itself. And with the GA comes that one-click option to perform in-place version upgrades to 8.4 as well. If you have done 5.7 to 8.0 migrations before, you know how convenient that is to have that one-click upgrade in-place upgrade. The next feature in the roadmap is Virtual Canary. I love this feature. With this feature currently in public preview, you can actually opt your dev, testing, or staging servers to be in Virtual Canary, which means that these servers will receive the monthly updates a little bit in advance. So it gives you an opportunity to perform an additional layer of testing on top of what testing that we already do. You can do an additional testing of these updates in your lower environments, and this will really help you avoid issues specific to your workloads like application level compatibility issues, etc. It is essentially really efficient way to manage your updates, and make sure that your dev, test, staging environments are all aligned. And you can do all of this with minimal disruption, right? There are many more enhancements coming to this feature as it goes GA this quarter. Probably in the next webinar, we'll cover more about the updates in this section. Next, Azure Database for MySQL bindings in Azure Functions, currently in public preview and going GA in a couple of months. As discussed earlier in detail today, this feature ensures native support for Azure Database for MySQL input, output, and trigger bindings for Azure Functions. What this means is you will be able to read data from an Azure function, from an Azure MySQL database into a function, save data back to Azure MySQL database, or even trigger a function when a change is detected in a MySQL table. And the next feature is error logs and server logs, which is now in public preview. This feature provides you the option to view and download error logs under the server logs option for up to 7 days, which will help you analyze and troubleshoot issues. It will be generally available later this year. And finally, a new and super exciting feature, self-heal. This feature allows customers to really quickly resolve server health issues like availability issues or key problems like missing logs or telemetry, etc., with just a single click. So with a single click, Azure MySQL will execute a series of automated steps and restore the server to a healthy status. So it will greatly reduce the need to contact support for small issues like this. Please note that we do publish all of these updates in a monthly update blog about 2 days after the webinar. And the latest update will be available always in this link, aka.ms/MySQL monthly update. Folks, that's all for today. As we close out, as always, I'll leave you with 4 things. First, check out our contributor initiative. Start contributing today and get badges, official recognition, and so much more. Second, to learn more about our service, you can use these resources, specifically aka.ms MySQL-resources, and you can feel free to reach out to us on our email ID. Third, you can stay tuned for more updates and announcements by simply following us on social media and subscribing to our YouTube channel. Our handle on YouTube as well as LinkedIn as well as Twitter is at AzureDB and we have the LinkedIn short URL here as well. And finally, if you want to feature in our upcoming webinars or collaborate with us in any way on any assets that we build out, fill out this form and let us know. Just like we had our MySQL partner, TCS today, collaborating with us on many more initiatives than just this, you can also get the opportunity to do so. Either fill this form or go ahead and apply for a contributor badge if you've already done some contributions or you're interested to do more. You can use the same form, in fact, to give any feedback on the session as well, or if you even have requests for suggestions for topics that you want us to cover in the upcoming sessions. All right. Perfect. So that's all. Thank you so much for tuning in. And we really hope you enjoyed this episode. We're going to do so much more in this field, try to get more industry experts like Biswajit and Abhirup today into the webinar. See you all in our next session on the 14th of May at 7:30 a.m. Pacific time. Thank you all.